Here, a galvanometer of resistance G, resistor of resistance R, and a cell of EMF E are connected in series. The key is open. That means the resistor S is not included in the circuit. The current will just flow from E, will pass through the galvanometer straight without any current dividing through S, will complete the circuit. The galvanometer shows a deflection theta. On closing the key, now when you close the key, G and S will become parallel. The deflection in the galvanometer becomes half. That means current through the galvanometer becomes half of the previous current. Initially, what was flowing, producing a deflection theta. Now the deflection becomes half, means the current becomes half. In a galvanometer, the current and deflection are directly proportional. Obtain an expression for the resistance of the galvanometer G in terms of R and S. In case 1, if you take, when the key is open, let the current be I1. So that current just flow through the cell galvanometer resistor back to the cell because the S is not included as the key is open. We can write current as total EMF, which is E, by the total resistance of the network, that will be G plus R. This is the initial current, what is passing through the galvanometer. Now, when you close the key, the current, total current will be different because now the resistance will be parallel combination of G and S. The total current passing through the circuit will be, again, the total EMF by total resistance. The total resistance include R plus the parallel combination of G and S. The parallel combination of G and S will be 1 by R equal to 1 by G plus 1 by S. If you take LCM and take the reciprocal, you get parallel combination G into S by G plus S. Or directly parallel combination rule is R1 R2 by R1 plus R2. So R1 R2 are G and S, GS by G plus S. Now the total current passing through the entire circuit will be I in the second case. When the key is closed, will be total EMF E by the total resistance, which include R and parallel combination of these two. This will be R plus GS by G plus S. If we take LCM in the denominator, that will be E by multiplying G plus S with R. So opening the bracket, R into G, RG plus RS plus GS whole divided by G plus S. That will go to the top as G plus S. This is the total current passing through the circuit from here. Reaching here, now the current will divide into 2. We need to find current through the galvanometer because that current is what given us half of the I1. This current what we got is the total current coming out of the cell. Only one part of that will pass through the galvanometer. The remaining will be passing through the resistance S. So normally there's a mistake. people will start doing I2 as half of I1. It's not I2 becoming half of I1. Current through the galvanometer is only half of I1. For finding the current through the galvanometer, we need to find the potential difference across this parallel combination, then divide by the resistance of galvanometer. Because in parallel combination, voltage remains same. The current will be voltage by resistance. So the voltage of the parallel combination will be current I2 into resistance of the parallel combination. So if we substitute that, it will come as E into G plus S by Rg plus Rs plus Gs, that's I2 into Rp. Rp is Rs by Gs by G plus S. G S by G plus S. In this G plus S get cancelled. So finally you get VPS E times GS by Rg plus Rs plus Gs. So this is the potential difference across the galvanometer. Now current through the galvanometer will be potential difference across the parallel combination by resistance of the galvanometer. So this value divided by the galvanometer. So G get cut. We'll get E times S because this G get cancelled by this G when you divide by G. So ES by Rg plus Rs plus Gs. Now what they told you, the deflection in the galvanometer becomes half means the current in the galvanometer becomes half. So that means this Ig, what you got now is only half of the initial current, I1. So this is the value of I1. Now Ig, what you have is Es by Rg plus Rs plus Gs. So it's directly coming from this Ig. That's equal to half. I can take this 2 to the left side. So 2 times. Yes. Then I1, what you got is E by G plus R. So EE get cancelled. You cross multiply 2 times SG plus 2 times RS equal to, this will go here, this will come here. So RG plus RS plus GS. This GS will go to the left. So 2GS minus GS will be just GS. This RS also will come to the left. So it will be 2RS minus RS. So 2GS minus GS will be just GS. Plus 2RS minus RS will be just RS. Equal to RG. The question is asking for resistance of the galvanometer. So take all G to the one side, same side. So this is a term with G, will go to the other side. So RS is equal to G common. R is already there. This will come as GS. So G common out minus S. So if you take R minus S to the left, Rs by R minus S will be the resistance of the galvanometer. This is the same result if you're doing galvanometer resistance by half deflection method in practical. It's the same result. There you don't derive this, you're just using the formula for practicals, half deflection method, how to find the resistance of a galvanometer.